Today we're going to continue using that sheet that I posted on the 27th, and we're going to talk about our linear and angular speed. So if you need to pause the video, go ahead and get this sheet out so that you can copy these notes down. If not, just do it in your notebook. So the first thing we'll talk about is, something that we are already familiar with is our formula relating distance, rate, and time. So say you're traveling in a car and you're traveling 25 miles per hour, that's your rate, and you travel for 3 hours, then you can, calculate your distance to be that you traveled 75 miles. But what if we needed to find out what that rate was or what our linear speed was? Um, so our linear speed is defined as the speed at which something moves around a circular figure. So if you had like a tire or a wheel or something, and you had something attached to it, to the rim of maybe your bike tire or something. So the linear speed is going to be the speed at which this dot here that I have drawn travels around our figure. So if this makes one revolution, then basically the distance that this dot would travel would actually just be the circumference of this circle here. So our linear speed, it's kind of like its speed as we know it, like your miles per hour, your feet per second. So if you're riding your bike and you know how many times your wheel travels or spins around and you know the radius of your wheel, then you'll be able to find out how fast you're actually going. Okay, so our linear speed, so basically what you need to know for this is you need to know your number of revolutions, so how many times the tire spins or the wheel spins or whatever the figure is, and you need to know the circumference. So our circumference is 2 pi r, or you can use pi d if they give you the diameter. And then you also need to know the time, over what period of time it gives you. So for example, if it says that something makes 4 revolutions per minute, then it would be 4 times our circumference over 1 minute. And then you adjust based on the problem. If they give you, number of revolutions per minute and they ask you for the speed, in seconds, then all you do is you have to adjust your time. And then whatever the unit the radius is given in, that's the unit that your numerator is going to be in. And again, if you need to adjust according to the problem, then go ahead and do it. Like if they give you the radius in inches and they want to know what the linear speed is maybe in feet per second, then you would just go ahead and convert your inches to feet. Okay, so for this one over here, so if I had something that went 4 revolutions per minute, that means like this little dot here would travel around 1, 2, 3, 4 times. So that's basically just 4 of my circumferences. So that's what linear speed is. And it'll be in units like miles per hour, feet per second, inches per second, stuff like that. Okay, your angular speed. So now your angular speed is the speed at which it moves through an angle over a certain period of time. So no matter how big or small your figure is, if you have a wheel or a tire and it rotates once in a minute, then the angle through which it moves in a minute would be either 2 pi radians or 360 degrees. So if it goes around once in a minute, then it's 360 degrees per minute. If it goes around twice per minute, then it's 720 degrees per minute. So the angular speed has absolutely nothing to do with the size of the figure. If it moves through an angle, no matter how big or small it is, it's going to there's only 360 degrees in a circle. So if it goes around once, no matter how big or small, it's just going 360 degrees. So for your angular speed, you need to know your number of revolutions, so how many times it spins, times 2 pi. So your 2 pi, that's one full rotation. And then again, it's just over whatever time they give you. So this has to do with its spinning, and then the linear speed has to do with like the distance that it would travel. Okay, so your equivalent ratios here. So our 2 pi radians, that's 1 revolution. 360 degrees, that's 1 revolution. When we do our angular speed, though, we are always in radians. I would say always. I would say 90% of the time we use radians. But you know that that's equivalent to 360 degrees. And then 1 revolution, if we're talking about our linear speed, then that's just the circumference of the circle or the tire or whatever it is that's spinning. Okay, so, and I think this actually printed on the second page for you, so sorry about that. But okay, so let's do a couple examples here. Okay, so this first one, example 5, it says the second hand of a clock is 10.2 centimeters long. So the second hand of the clock, so you guys know that, you know, your clock hands are attached right there at the middle. So the second hand, whatever the length of it is, that's going to be the radius. So R equals 10.2. They want to know the linear speed of the tip of the second hand in centimeters per second. Okay, so I always check out our units here. They give us our radius in centimeters. They want our answer in centimeters. So we're not going to have to worry about converting that at all. And then they don't give us the time here, but it's a clock, right? So find the linear speed of the tip of the second hand in centimeters per second. Well, how long does it take for the second hand to move around 1 revolution? Well, it takes 60 seconds, right? Because it just ticks a full minute, but they want our time in seconds. So we're just going to say our time here is 60 seconds. And then our number of revolutions, well, again, they don't actually state it, but because it's a clock, we know that in 1 revolution in 60 seconds. So we're just going to use 1 for that. Okay, so the linear speed, all that is your revolutions times your circumference, which is 2 pi r. Over the time, and we're deciding to use our 60 seconds as time. Okay, so the tip of the hand. So basically what they want to know is as this moves around and ticks around here, what's the distance it would travel? So that's just going to be your circumference. So that's why we're using this 2 pi r. And then from there, all you have to do is fill it in. So number of revolutions, of course, we're just using 1 revolution per 60 seconds times 2 pi r. So 2 pi times our radius, which is 10.2. All over 60 seconds. I like to put my units in because my radius here was given in centimeters, so I like to put my units up top and my units on bottom, so that way I can make sure that I'm in the correct units when I give my answer. So they want our answer in centimeters per second, and here we are, centimeters per second. Okay, so then all you're going to do then is multiply this out. Sometimes they'll leave the answer in radians, and sometimes they'll have the answer with pi multiplied out. So if we multiply this, just multiply this all out, then you're going to get 1.07 centimeters per second. Okay, so when we're doing our linear speed, they're usually going to multiply that out. Okay, so let's try another example. So for this one, example 6, they're having us find both the angular speed and the linear speed. So it's a good idea to kind of write your information down here. So they're going to give us the diameter. So I'm just going to go ahead and use the diameter in the formula instead of using the radius. Revolutions, they say a 15-inch diameter tire on a car makes 9.3 revolutions per second. So I know my revolutions are 9.3. per second. So my time that I'm going to use is 1 second. Okay, so that's kind of like your list of information you need. So for your angular speed, all you need to know is your number of revolutions, which is our 9.3, times 2 pi, because it takes up 2 pi radians per revolution. So number of revolutions here times the angle that it moves through over our time. So our time here was 1 second. Okay, and then you can just multiply that out. So your angular speed is like the one that sometimes they multiply pi out and sometimes they don't. So if you guys want to go ahead and write your answers both ways, so we would write it as either 18.6 pi, that would be radians per second, or you can just go ahead and multiply that out. 18.6 times pi is going to give us 58.43 radians per second. So that's the angle, that's how fast it spins basically. Okay, and then when we go to find our linear speed, now we're going to do the number of revolutions times our circumference. Our circumference, of course, you can use 2 pi r or just pi d, so we're going to use 15 pi. And this was in inches, our diameter was given in inches, so I'm going to go ahead and put my unit there. And then our time was 1 second. So before I multiply this out, I double check. Find the linear speed in inches per second. So if we look here, inches per second. So we're actually good to go. All you're going to do is you're going to punch this in your calculator, go ahead and multiply pi out. So you would end up with 438.25 inches per second. So the only difference between angular speed and linear speed is the radius. So if you notice, this here was 9.3 times 2 pi, and this is 9.3, and this is your 2 pi r. So the only difference, the linear speed, you multiply by the radius, the angular speed, you do not. Okay, and then, sorry, this is a little bit of a longer lesson, but I wanted to make sure we did enough examples so that you guys could be successful today. All right, so the circular blade on a saw has a diameter of 7.25. Again, it's good to like make a list of information. So I know we have our diameter, 7.25 inches. Rotates, so those are my revolutions. 4,800 revolutions per minute. So then my time, whoops, is in minutes, so 1 minute. I don't know what that is. Hold on. Okay, so there's my information. Find the angular speed of the blade in radians per second. Okay, so I'm going to look at this right here, second. So angular speed is revolutions, so 4,800 times 2 pi. It's the number of revolutions times the angle, so 1 revolution goes through 2 pi radians, over time. Our time, they're asking us to give the answer in seconds. They give us our time in minutes. So whenever you set this up, you can just, instead of putting 1 minute here, just go ahead and put 60 seconds. Okay, and then you go ahead and multiply that out. So this is going to give us 9,600 pi, that's radians, per 60 seconds. Okay, so then if you reduce this 9,600 over 60, you get 160 pi. So that would be in radians per second. And then if you go ahead and multiply pi out, you end up getting 502.65, and we'll just go 2 decimal places. Again, radians per second. Okay, so those are both the answers if you leave pi in or if you multiply pi out. And then if we want to go ahead and find the linear speed for this, so we want our linear speed of the saw in feet per second. So take your number of revolutions, 4,800, times your circumference. So they gave us the diameter, so I'm just going to use pi d. So 7.25 is my diameter times pi. So that's my circumference right there. Now this is in inches. So put your unit there so you can keep track of things. Whoops. Over our time. So they want, again, they want this in seconds. So since they give us our time in minutes, let's just go ahead and put 60 seconds down here. So that's one less thing you have to convert later. Okay, and then from here, you can go ahead and multiply if you want. So if you multiply 4,800 times 7.25, what do we got here? So we end up with 34,800 pi inches per second. They want our answer in feet, so you're just going to do a quick conversion here. So 1 foot and 12 inches are equivalent. So your inches are on top here. This is that dimensional analysis. You want to make sure when you're doing your conversion, your inches are on the bottom so that the units will cancel out. So we have 12 inches down here and 1 foot. Okay, so your inches, see how they cancel off? And then the only units you have are feet and seconds, and there we go. They want it in feet per second. So you're all ready to go. And then just punch that in your calculator, and you should end up with 151.84 feet per second. Okay, and then our last one. So a woman is riding a bicycle whose wheels are 30 inches in diameter. So I'm going to put my diameter down here. The wheels rotate, so rotations, revolutions, same difference. So those are my revolutions, 150. So this RPM, revolutions per minute. So my time is 1 minute. Find the speed at which she's traveling in miles per hour. So this miles per hour, this is your linear speed. So we're looking for a linear speed here. So you're going to take your revolutions, which are 150, times your circumference, so pi d, so 30 pi. So your diameter was given in inches, so right now we're in inches. And the time is minutes, so we're in 1 minute. And then we could just go ahead and multiply this all out, but first I'm going to make sure we go to the right units. So we need to go into miles per hour. So let's take care of our hours first. So 60 minutes, again, you want your units on opposite sides of the fraction bar, per 1 hour. That's going to take care of the time. Now we need to go into miles. We're in inches right now. So my inches are on top over here. I'm going to put 12 inches on the bottom per 1 hour. So now not 1 hour, 1 foot. Okay, so 12 inches and 1 foot. So see, my inches are on top here, inches on bottom here. So now we're in feet. We have to go to miles. So we want feet on the bottom now, since our feet were on top here. We want them to cancel. And then mile is 5,280 feet. Okay, so now you're ready to go. All you have to do is punch this in your calculator. So if you look here, minutes cancel, inches cancel, feet cancel. So if you look across the top, the only unit you have are miles, and if you look across the bottom, the only unit you have are hours. So we are now in miles per hour. All you have to do is punch this in your calculator. What you have to be careful of, though, is because we have more than one thing on the bottom, you want to make sure you're going to put everything in parentheses. So put top in the parentheses, put your bottom in parentheses, and then when you multiply this all out, this woman is traveling at 13.39 miles per hour. Okay, so on the, I think it's the last page, try the linear and angular speed problems, numbers 8 through 12, and then later I'll put, I mean, the answers are on the bottom, but I'll post like the worked out solutions a little bit later this afternoon, so that you can see what all the steps are. We're going to be practicing this for the next few days. So if this isn't sinking in right now, don't panic, but please email me and we can set up tutoring, or we can do a Google Meets, or drop into office hours and ask questions if you have them. So, all right, sorry that was long. Have a nice day.